good morning. This topic's name sounds harder than it is, but it is a topic that you have kind of a lot of choice, and that makes some people uncomfortable. Solving right triangles just means finding out all the missing parts. All right, that's all you have to do. Now, in order to find out all the missing parts, you might need to employ a few different strategies. At some point, you may need to use our little good buddy Pythagoras, right? We might need to use that if we know two sides and we're looking for another side. We will need to use the trig functions and the inverse trig functions. All right, remember we use the inverse trig functions when we're looking for an angle. We use trig when we know an angle and a side, and we're looking for side. And we use Pythagoras when we know two sides and we're looking for another side. All right, so those are the things that we're going to be doing. So here is a right triangle. We know two bits of information. We need to know more. Oh, you know what else you might want to use? The angle sum theorem from geometry, which is that the angles in a triangle add up to 180 degrees. All right, so we might use that too. That's the first thing that pops in my mind when I look at this picture, probably because I'm teaching that in my geometry class right now. So you can go about these in any way, whatever way you think of at the moment. So for example, the first time that I look at this, I'm going to be like, hey, I know these two angles are complementary, so that it adds up to 180. So that should be 18 degrees. All right, so angle B is missing and it's 18 degrees. Now let's look for the sides or whatever. You have a lot of freedom here. So I'm just going to kind of go with it the way that my brain is thinking about it. I want to know the hypotenuse right now. That's just what pops in my head. The hypotenuse is AB, right? So in order to find AB, I can use trig functions, whichever I want. I'm going to look for this part here. And so for my head, I'm looking at sine, right? So I'm going to do the sine of 18 is equal to the opposite over the hypotenuse that I don't know. I'm going to multiply both sides by x, or if you figured out any shortcuts, then you can use those. So x sine 18 equals 15, and divide by sine 18. Using my calculator at this point in degrees mode, I'm going to do 15 divided by sine 18, and it gives me 48.5. And from there, we can do a couple different things. We can use the Pythagorean theorem in order to figure out CB, which is our other missing side. That's what pops in my head to do for this problem. So I'm going to have 15 squared plus something equals 48.5 squared. So I'm just going to square the last thing in my calculator. Equals 2356.2. Subtract 225. And take the square root, which is 46.2. Or so. So these are approximate answers we had to round because these aren't special right triangles and we did not ask for exact values. All right. I'm going to show you one, or I guess I'll show you both, but if you feel like you got it, you're welcome to move on. For the next one, I'll just kind of go about this one a different way. I'm going to just look for ST first. No real reason. It's just kind of the way that my head works. So that is a cosine relationship. So over here, I'm going to do cosine of 34 equals adjacent, which is our x this time, times the hypotenuse. Solve that the way we solved those guys. 42 cosine 34 is 34.8. All right, we also need to find this side, which I could do for finding RT. If I felt like it, I could use sine now, because from this angle, this is opposite and hypotenuse. So I could do sine of 34 equals something over hypotenuse. So 42 sine 34 equals x, and I can just type it in, 23.5. Now, could I have done the Pythagorean theorem? Yes. Could I have done tangent? Yes, I could have done quite a few different things. And then the last one, I could use trig if I wanted to find that missing angle. So I'll do that just for fun. I'm going to go with tangent because why not? Tangent theta. So here's going to be our theta is opposite over adjacent. And I can do inverse tangent of 34.8 divided by 23.5 is about 56. Now, you can see how very nice this is because these need to add up to 90, right? 56 plus 34 is 90. So it works. You could have done it that way too. There's a million different ways. All right, so for this one, I'm going to go with Pythagorean theorem first because that's what jumps out at me. So a squared plus b squared equals c squared. I have the two legs. Just going to type that in. 947.25 equals x squared, and take the square root. 30.8. All right, now we can use any of the trig functions because we know all of the sides to find this. First, you need to decide which angle you're basing it off of, so I'm going to go with that one. And I'm randomly going to choose sine. Sine theta equals opposite over hypotenuse. Since we're looking for an angle, we're going to use the inverse. Second sine, 22.5 divided by 30.8 is 46.9 degrees. And we can do the other one by doing 90 minus 46.9. 43.1 degrees. All right, so we know that our missing side DF is 30.8. Angle D equals about 46.9, and angle F equals 43.1 degrees. All right, hopefully that gives you a good kind of strategy, and have a great day.